Hi, this is Eric with Technically Speaking at Source Allies. Today we're going to be talking about how to configure hot reload for your web app in Kubernetes. Hello, and welcome to this video about Kubernetes, hot reload, web development, and all that nonsense. If one of those things sounds interesting to you, hopefully you'll find something cool here. We're going to have a really short one today. We're just going to be talking about how you, as a web developer, can run your development workflow with hot reload and everything within the Kubernetes cluster. So why might you care about this? Why would we want to do hot reload in cluster? Well, one of the things when we're doing software development is that we want to have our development environment look as close to the production environment as possible. Obviously, we're not going to get it to look exactly like the production environment. You're not going to be running your silly little web app on some server with 64 cores and 500 gigabytes of RAM. But we can get pretty darn close. And luckily, there are plenty of tools out there to make this super easy, and we're going to do it all from scratch. Obviously, you don't have to do this from scratch. There's probably going to be a million better ways to do this. And if you know a better way, definitely comment it down below. I want to hear about it. But we're just going to be something real simple from scratch, how you can do hot reload with your web app inside of the cluster. So it's going to get as close to the production environment as possible. So in order to do that, we're going to be using a couple tools today. We're going to start out with Bun. You don't have to use Bun. Dino, Node, all the different frameworks out there for web, they all support different kinds of hot reload or something like that. But I'm just going to choose Bun today because I like their little icon and I think it's kind of cool. The other tool that we're going to be using is Kind. So if you're not familiar with Kind, it is a CLI tool that aims to make Kubernetes development a lot easier. So Kind will spin up a cluster on your machine. By default using Docker, you don't have to use Docker, you can use other things. But Kind will make it super easy to get a cluster set up that you can start developing on. Let's take that hypothetical scenario I described where you are a CSS ninja and DevOps isn't really your thing. So you're probably going to be starting with a web app as opposed to starting with a cluster. So let's just create a simple web app in here. We'll do Bun init, we'll do React because we love React, we'll select Tailwind because we love Tailwind, and we'll let it do its thing. So it just spat out a bunch of code in here. But hopefully this is stuff that's pretty familiar to you as a CSS ninja. You might come over here and see that, oh yeah, we got our app.tsx. We got, oh, this is a frontend.tsx. Interesting. We have an index.tsx, and we can see that inside of here, we have a serve thing going on. So this is just Bun's little React template. It kind of demonstrates that Bun can do a lot of different things. We don't care too much. What we really care about is that when we run this with the default script, we can do bun dev, and then that will do hot reload starting with index.tsx. So let's clear that out. We'll do bun dev and take a look at this. Look at that, we got our app running, and we can also do the little server side thing. That's not what I'm going to be talking about today, but it's there. And it's running, it's on localhost 3000, and everything is hunky-dory. So we have our nice little Bun app here, and that's super great, but it's not going to run in it's not going to run in the cluster without a container. So let's use Docker to get our container built. We'll create a Docker file. And then luckily, Bun has some nice little copy-pastable stuff that we can throw in here to get our Docker container kick-started. So obviously, you don't want to just copy-paste stuff, and we'll talk through a little bit what exactly we're copy-pasting here. In fact, we're going to modify it too. But just to make things a little bit faster, let's copy the Docker file from the Bun website and then kind of talk about what it's doing. Over here, we're just taking from the oven bun base image, and we're going to install our dependencies. That's a Docker best practice. It helps with build caching, so you don't have to reinstall your dependencies every single time. And then down here, we're actually going to run tests and run our build. And this is all super great if we had just like a regular old Bun app. You know, if our index.ts was performing, you know, just some service load, but we have a website. And typically what you would do next is you would delete most of this. What we can do to build our website is, that's a part of the Bun build. So we can go look over here. We have our build script, which just does bun run build.ts, and then we have our build.ts over here. And they generated a lot of boilerplate. I think it just kind of demonstrates how flexible Bun is with the things that you can do. They expose a lot of their API directly. So you can use the build process that the CLI uses just directly in scripts, which is super cool. And you can see that we really only care about what it does. It is going to give us some options that will allow us to specify, like the out directory. We can minify it. We can have source maps and all that fun stuff. So TLDR, we want to bun, run, build, and this will spit out our dist directory. So this is the distribution. This is all of our static assets that we would serve up. We have our index.html. It's got our bun React. It's got all of the JavaScript and all that nonsense. So in our Docker file, this is also what you would probably do. You would probably do your build and you would put your static assets in a place that a web server could serve them from. So we'll just say maybe we want to do bun, run, build, and then in our final, we'll do from base as prod. How about that? We will copy from and pre-release, and we want to copy our workdir was, what was our workdir? It was user source app, and we want to copy dist. And let's just put it at serve www. Doesn't matter. So this is what your Docker container might look like when you were going to deploy to production. But you might notice that this just spat out static assets. Like, sure, we can use this, but we're not going to get hot reload or anything cool like that. Well, that's where the fun part starts. So let's just get rid of all this. We don't even need this. What we are going to do is we are going to set up a kind cluster, and we are going to run bun directly from the cluster. We're going to mount our workspace. We're going to run bun with hot, and we're going to get hot reload, and it's going to be freaking awesome. Like I mentioned, we have to mount our workspace within the cluster in order to get this to work. So we need to utilize the kind configuration, and luckily they have a nice little configuration reference over here on their website. So you go to kindsigs kates.io and you go over to the configuration, and this will describe how you can use a configuration file for your kind cluster. So the kind config is kind of laid out as if it were a Kubernetes resource. So you have a kind, the kind is cluster, and you have an API version, and that's your kind x kates.io, v1, alpha, whatever. It doesn't really matter. So we're going to mimic this. We're going to do a little bit more copy pasting, but we'll talk about what we're copy pasting, and we'll get a kind cluster created that will be mounting our workspace so that we can run hot reload on it. So let's go ahead and let's create a YAML file back in our repo. Let's create kindconfig.yml, and I'm a YML person, not a YAML. I think the A is too many letters. We don't need that many letters. We'll create our kind cluster. We'll say our API version is, what was that? This is where the copy pasting comes in. Kind x kates.io, v1, blah, blah, blah. Copy that. Take it over here, paste that there. And now, if we did kind delete cluster, and now when we create our cluster, we can pass the config flag, kind create cluster, config, and we'll give it the path to our YAML file. So this is going to do exactly the same thing that we just did. We haven't actually provided any configuration yet. So while that's doing its thing in the background that we're going to delete in a second, let's actually go look at the configuration. So you'll see there's some stuff here at the top that we don't really care about too much. We can provide a name for our cluster. Won't be doing that. Just too much cruft. This is a tutorial video. They're supposed to be simple. But what we do care about are mounts. So let's see if we can search for the mounts section. So here, now we have our extra mounts. So we're going to be utilizing this to mount our workspace path inside of the Kubernetes node. So we have to remember what's going on here is that we have a cluster running inside of Docker, and we can see if we do docker ps, we'll see that we have an image running here which represents our kind cluster. This is the control plane. So what we first need to do is we need to get our workspace inside of this. And once it's inside of this, then we can worry about mounting it inside of our pod. This represents sort of what a physical machine would be in production. So if you can imagine that if we were running on a physical machine, we wouldn't have this extra step. But since we're running the node inside of Docker, which is a virtual environment, we have to do that extra little mounting step to get things set up as if it were a real machine. So let's go back to the docs and let's see what they're doing here with the extra mounts. So it looks like we have our nodes configuration, and this is for the control plane. So we want to do the same thing. We saw in our little Docker PS that what we have running here is we have a control plane node, and we want to mount our workspace inside of that control plane. So we'll take this bit, because this is the part that we care about, and we're going to take this part, we're going to copy paste this, we'll delete the comments because we don't care about the comments. But let's see, we also have to have our nodes. So we'll have our nodes declaration. We'll have an element in this array that specifies we're going to configure the control plane, and then we'll give it extra mounts. So the host path here is going to be the host path on my machine. So we are talking about a physical machine right now. And we'll do print working directory. This is the path on my machine. When you actually go to check this in, you'll want to use relative paths. But to make things simple, we'll just give the full path here. And then inside of the container, so we're talking about our control plane node container, we will just put this at the root of the container and we'll put it under source, just because it's mimicking the source of our source code. And we'll give a final new line because I like doing that. We will delete the cluster that we created a second ago. And now we will do kind create cluster, and we'll give it the config again. So now what this will do is when it spins up that control plane node, it will have our workspace mounted inside of it. And we can demonstrate that the workspace exists and is ready for us to use. So go over here, we go look at our Docker container. See Docker PS, we still have the thing running. And then if we do Docker inspect and give it, what's it called? We need the name of that container. Docker PS, and we want to do inspect, Docker inspect, give it that. And then if we look for mounts, let's grep for mount. I think they capitalize stuff. Yeah, there we go. So do grep, and then we'll give it some space with -n. Oops. There we go. So now, oops. Didn't give it enough space. Let's give it some more space. Nah, it's hiding down there. Let's instead, how about we Docker inspect and let's pipe this to less. There we go. So now we go find our mounts, and we can do that with /mount and n. There we go. All right, so we can see finally that we have our bind mount into the cluster. We can see that the source is that path on our machine, and the destination is source inside the cluster. So we'll leave it at there for now, but we'll come back to that later once we have a pod running. So now we need to have a pod that's going to represent our actual app running inside of the cluster. So we'll just create a new pod YAML file, and we'll open this up. And what we're going to do is we're going to create a Kubernetes resource. So now you, the CSS ninja, are probably very confused as to what this is and what the heck we're doing. So let's go look at some docs for that as well. If we go over to the Kubernetes documentation, kubernetes.io, and we go over to documentation, and let's just go down to pods. So we have, where is it? Cluster architecture. Let's just search for it. How about that? Searching is always better. So we'll go and we'll search for pods, and we'll go to the pods documentation on the Kubernetes website. So pods are the smallest deployable units of computing that you can create and manage in Kubernetes. So a pod can consist of multiple containers, but we're going to be using a single container for this example. So because of that, you can, in your head, equate a pod to be a container inside of the cluster. So that's all the more that we will need to know about that for this example. So let's go ahead and create one of those. So we're going to create a kind pod, and you can see we have a little snippet that's going to try and help us out, but this is a tutorial, so we need to do it ourselves. And the API version for pods is core v1, but the whole thing in Kubernetes with the core is that you can just do v1. So we put v1 there, and we can see that VS Code has kind of recognized that's what we're doing, and it's going to give us a little bit of IntelliSense, which is kind of nice. So we'll start out with some metadata, and we'll give it a name, and we will say that this is going to be called hot reload demo. And the namespace we'll leave as default. So if we just do k get pods, that will look for the default namespace. So we don't have to pass any namespace arguments as we're doing this. So now we'll give it the spec. And what we want to do is we want to say that we have a container. We'll call it dev because this is our development container, foreshadowing. And we'll give it an image. And we can use the exact same image that the Docker file example used, and we'll give it a command. And for right now, we're going to leave this blank, but we're going to be running bun commands here. And what I want to do next is I want to talk about the volumes. So this is where the meat and potatoes come in. So we've done our first volume mount, and now we're going to be doing our second volume mount. So this is the one that's more realistic. We don't have to worry about the fact that we're running our cluster in a virtualized Docker environment. This is going to be the same for any Kubernetes thing that you're doing. So in order to provide the volume mounts, we first have to have some volumes. And if we go over here and give it, let's see, spec containers. I'm missing something here. I like the IntelliSense when it works. Let's give this just empty crap so that it's stop being mad at us. Resource limits. That's linting. We don't care about resource limits. Use all my resources. But I think that will, yeah, there we go. So then we can do volumes, and we'll give it a name. It does not matter. We can just call it dev. Actually, let's call it workspace. This is our workspace. And our mount is going to be host path. So now you may be thinking like, oh yeah, that's going to be our print working directory, but no. Remember when we mounted our working directory or workspace in the cluster, we put it at source. So this is what we're going to be mounting into the pod. This is the physical path on the machine that we want. So we'll give it source, and we will then reference that up here. So just to keep things simple, let's put it in the same path. And the name is workspace. Oops. So now we have a simple pod definition that will mount this in the workspace. And let's give it a command. Let's make it sleep. Sleep infinity. So that way we can log in and take a look at it. So now if we do cube control or k apply, and we'll give it our pod YAML. Let's see if this fails. There we go. Pod YAML resource name. Oops. Let's see. Resource name may not be empty. What did I forget? Metadata name hot reload demo. I'm missing something obvious here. Resource, v1, pods, group version kind, v1, kind pod. Yeah, it's not picking up our name. Okay, I must be doing something stupid here. Metadata. Oh, there's an extra T in there. That's embarrassing. I had too much tea. I drank too much tea today. Let's try that. All right, there we go. In any case, we have it now. So let's just back to our shell that has a little bit nicer view of things. We can do k get pods. And since we're only looking at the default namespace, we have this. So we can do k exec, and let's exec just the ls command, and we'll do the source directory. So, oh yeah, and it wants me to pass the double dashes. So let's just fix that, best practices and all that. So you can see, hey, look at that. We just executed the ls command at the source directory of our pod, and we can see, hey, this looks pretty familiar. This looks like the code that is in our workspace. So what we've done is we've now mounted the workspace from our machine inside of the kind cluster, and then mounted that inside of the pod that's running inside of our kind cluster. So this is super awesome. The hard part's over. Everything after this is going to be super easy. So like I said, we're going to be coming back to this command, and now we can run the bun stuff. So what we want to do is simply run the exact same thing that we would on our machine. We can do bun dev, and that will start the web server and block and serve everything up. So we'll need to give it a port here, but just to show that this works, first we need to delete the pod because pod stuff can't be modified. Kdelete pod.yaml. I think we need to do -f. So if we do k apply -f pod YAML, we'll create that, and then we'll go take a look at it over here, and we will see that, aha, script not found dev. That's because we didn't set the working directory. Let's go set the working directory on this container. Working dir source. There we go. Kdelete. Apply. That one went faster. I don't know why the other one was so slow. There we go. All right. So now if we go over here, we'll do klogs, and we see that our server is running. So we won't be able to access this because we didn't expose any ports. And that's because we have to do the host port as well as the container port. All right. So what I just did off screen, hopefully off screen, Haley, it's going to be off screen, is I just added the resources here just so that the yellow goes away because it was bugging me. But what we want to do is we want to give this a port to expose. So if we go over there, give ports, we know that our thing is running in the container at port 3000. And if you're familiar with Docker, this should be pretty familiar as well. What we'll also do is we'll give this a name. We'll just say it's HTTP. Just makes it easier to reference. And now, if we do our delete apply rigmarole and go take a look, we'll see that it is once again running. And if we click this and try to access, aha, it doesn't work. It's because we have another step to do. So this is very similar to volume mounts. We have exposed the container port from our container, but we haven't done anything at the cluster level. So in production, there are many different ways to do this. You could have an ingress with a service. You could have a gateway. Any plethora of things. But this is just a local development workflow. We don't need to install an ingress controller or anything fancy for what we're doing. We can just do simple port mapping. So if we go back to the kind configuration, we'll see that, oh, hey, there's this nice little extra port mappings as well. So we're going to take advantage of this to make things super easy. Barely an inconvenience. I hope somebody got that reference. So we'll do a little bit more copy pasting. We're going to take these extra ports and put that down here alongside our extra mounts. So we have a very similar thing going on. We're still configuring our control plane, and now we're giving it some extra port mappings. So to keep things simple, we're just going to use the same port all over the place. So we're going to do 3000 because that's what our web app is running on. In production, you'd probably have a little bit more to worry about. You don't want to have ports conflicting with things. Like, obviously, you can't run all of your web apps on port 3000. I mean, you could, but we don't want to. We're just trying to keep things simple. So we want to delete our cluster and recreate it using this new config. Luckily, this is very fast. See, the nice thing about doing this kind of stuff for development is it's all really fast. You want development to be fast. The things in prod, they can start up, they can take a minute or two to load up, but when you're doing local development, things should be super fast. So we can now get pods. We'll see that we have nothing in there. But when we go to do our port mapping over here, we need to give it an extra thing. So we're going to use a host port here. What kind has done is it has effectively mimicked a host port. In fact, I think, I forget how this works exactly, but I think we can just do a, if I can type the word clear, Docker inspect, that's not our container ID anymore. Docker PS, go look at that. We'll do Docker inspect. Boop, boop. Less. And if we search for, oh, hey, there we go. It's already on the screen. So we can see how we have our port bindings down here. So we have 3000 bound to the host port of 3000. Now, if we go here, we're not quite done yet. We don't have our container running, but we can just go see that, oops, that's not the right port. Still nothing's happening. But when we go to run our pod, kapply, pod YAML, go back over here, Q, escape, Q, come on. Get me out of here. There we go. If we do K logs, still the same thing, but now, oh, tension is building. Go to the browser. Oh, look at that. Look at that. We have our nice little web app running in the browser inside of our cluster. Now, I did say that this was hot reload. I did say that. We have not done hot reload yet. But you would think that we've just simply mounted a bunch of file systems. Hot reload should be pretty easy. Let's see. What if we open up our source and we go and we just modify this? Let's take our heading here, bun plus React, and let's say source allies rocks, because we got a coworker that goes by Rock, and Rock is really cool. So let's do that. Now, if I am to be believed, we should now see that we have hot reload working in the cluster. What do we have here, and why is it different than what we were doing before? Well, the main difference here is that we now have our same web app running inside of the cluster. So I mentioned at the very beginning that this template was actually sort of a little server-side front-end mix. And we have the front end, which is doing the React stuff. And if we go take a look at the index.ts, we'll see that same serve method that I touched on before. So this code is running server-side. This is running in the bun environment. And when we have this code running, this will be running inside of the cluster. So what we can do, for example, is we could new up the Kubernetes client. We could do new, I won't actually install the Kubernetes package, but you could do new Kubernetes, and we could list pods. I don't know what the code for that is offhand, but what we have now is we have an environment that is going to be much closer to our production environment. And if we're running into errors, or we just are doing Kubernetes stuff or anything like that, it's going to be a heck of a lot easier to develop on your machine the same way that your code is going to be running in production. So what did we talk about today? We talked about how you can get your web app and your development workflow running inside of a Kubernetes cluster almost completely from scratch. We used bun, we used kind, but we wrote most of it ourselves. All the volume mounts, all the commands, they're all the same sort of things that you would be running on your machine, and we've been able to do that in the cluster. So anyways, this has been Erik Rasmussen with Technically Speaking at Source Allies. Do you have a topic that you want to see covered? Comment it down below. And check out sourceallies.com to learn more about us. Thanks for watching, and we'll see you next time.